Howdy. My name is Victor Johnson, and I'm a meteorology major at Texas A&M University. Today I'll be giving a presentation on heat waves and drought. In today's time, you hear a lot about the impacts of heat and how it affects everyday life and the world today. And so for this presentation, we'll first formally define a heat wave and a drought, and then we'll look at how those two events develop. And once they're developed, we'll look at how they interact with the environment to empower themselves and then take shape across the nation. And then next, we'll look at some graphics and the impacts of those two events. And then finally, we'll look at some record events. And one thing to keep in mind is that between a heat wave and a drought, when you have one, you typically get the other two, in which typically dictates the conditions that happen for a certain period of time. And so for heat waves, it's formally defined as a period of at least 5 days where the daytime high exceeds the 90th percentile for each day. So typically, the 90th percentile is considered about 10 degrees above average. And so this type of event is often associated with La Nina conditions of the Pacific Ocean. And so in case you haven't been quite familiar with the terminology, there seems to be a sort of a connection between the temperatures of the Pacific Ocean and how they impact the type of weather that we get across the United States. And so with El Nino conditions typically give you more wetter, cooler periods where the Pacific Ocean is warmer than average, but in the La Nina stage the water is cooler than average. And so you typically get drier, warmer conditions there. And as for a drought, there are actually several different ways to define a drought, but I'll go over the more important one, which is the meteorological definition. And this is considered a period of simply abnormally dry or below average rainfall conditions. And so how intense a drought is really just depends on how much rainfall the area has gotten compared to average. And so the more below average you are, the more intense the drought is considered. And so there are actually several different ways to define a drought, but two of the most commonly used ones here are shown on the screen. And so one is the Palmer Drought Severity Index, which is based on a scale of -10 to +10. And so this index takes into account the rainfall received over last month, and which is effective for comparing records on a climatological basis, or for example 30 years. And so with more drier conditions or below average rainfall, you get negative values, but with more rainfall coming in or getting above average, you get those positive numbers. And another index is a specialized precipitation index. And so this one's typically considered more effective than the first one because it can be used on not only a long-term basis like climatology, but also for a short term. And so unlike the first one, this one takes into account all the records given from when records were first being kept. And so instead of going off the last month, we can take a comparison off of the entire time to see where how a certain month falls according to time. So in this way we're avoiding some possible confounding effects that we see when we just take into account, for example, June of 2016, and comparing that to July of that year, and which would be less accurate than comparing that to all the time that records were kept during on a certain place. So Now let's take a look at the upper atmosphere. And so over on the United States, towards our east, there's a semi-permanent high pressure system located over the Atlantic Ocean, and this system we call the Bermuda High because it's located very, very close to the Bermuda Island in the Atlantic Ocean. But to our west side, there's another semi-permanent high pressure system, and we call that one the Pacific High. And so typically on a day-to-day basis, you get weather systems that come in and shape the weather, like low pressure systems here, or maybe another ridge that comes in. And typically in a normal summer, there's no high pressure system over the United States like you see in the two oceans. But typically if a drought is happening, it's probably because there's another ridge that's over the United States and that's deflecting those disturbances and thunderstorms coming that would have been giving the precipitation if it wasn't there. Looking at the upper atmosphere, here is sort of a diagram of the flow of air around highs and low pressure systems. And so this wavy pattern you see here is called a jet stream. But I want you to take a closer look at the two areas that are circled. And so just east of the high pressure system on the left, it's an area where wind tends to slow down or converge together. And typically what happens is you get sinking air. And when air sinks, it tends to warm up. So over this area, the air is stable and dry. And so this is typically not conducive for getting precipitation. But if you go east of the low pressure system or west of the high pressure system on the right, you tend to get air that diverges or speeds up. And this is an area of rising motion, like the opposite of the first one. And so instead, the air is conditionally unstable or moist. And so this kind of air is better able to support precipitation or thunderstorms. Now diving a little deeper, let's take a look at upper level heights to surface phenomena. And so there tends to be a strong correlation between surface temperatures and upper level heights. And typically in meteorology, we call this the 1,000 to 500 millibar thickness, because our atmosphere can be thought of as sort of a container of gas that is compressible by definition. And so typically, as you go up, the pressure drops and so does the temperature. But if you go down, the opposite happens. And so we can think of high pressure aloft as associated with higher heights. And typically in winter months like January, February, and December, you get less daylight, and the side where the United States is on of the Earth tends to receive less direct sunlight from the sun. And so you tend to get cooler temperatures and therefore those lower heights. But as we get into the spring and summer months, it tends to warm up. And so you get more daylight coming in and a more direct position facing the sun. And so with those higher temperatures, you tend to get higher heights. So maybe now we want to know how does a drought form in the United States? Well, typically this has much to do with where those high pressure systems were located from those previous slides. And so for the central U.S., typically what happens is you have a ridge that's located over Mexico during the early summer months. But then sometimes it moves northern into the U.S. interior, and then it just stalls out. And so what happens is while it's there, it's sinking the air and deflecting all that precipitation, the precipitation that would have been coming in, and you don't see those moist or cooler air masses coming in. So you tend to get hot, dry conditions that last for quite a while. However, on the eastern U.S., there are actually two ways a drought can happen. So first, you can have a high pressure system just sitting over the area and just bringing you those hot, dry conditions from the sinking air over that area. But however, another way that this can happen is to have that Bermuda high moving. So typically the semi-permanent ridges are in place all the time throughout the year, but they move around just a little bit, and so sometimes the high can move west, and because it's a ridge, it deflects all those rainstorms and rain clouds away, and so you tend to get dry conditions over the eastern part of the United States. And on the western side, it's known for being dry most of the time throughout the year. And typically, what happens is this is all due to the hot, dry conditions from the presence of high pressure aloft, which sinks the air and keeps the air expanded. So then you just can't get precipitation or thunderstorms to come in to give you that relief. But then one cool thing we started to notice over the recent years is that we've started to see sort of a slight shift in the disturbances that come in during the cooler months, like for example the atmospheric rivers and those broad low pressure disturbances that form over the Pacific Ocean. And so we started to see a slight more shift in relief that comes in during the cooler months. And so now the ridge is set up and it's taking shape, but however it also tends to interact with the environment, and what happens on the surface tends to dictate what happens next. So and this all has to do with certain feedbacks right here. So one of them is dry air, and so compared to moist air, dry air tends to sink, but moist air rises. And remember, with sinking motion, you raise the temperature and it dries out, so you can't get any clouds or saturation to help or at least entertain the possibility of rain or thunderstorms. Another is dry ground, and so without rain, the ground just dries out. Now, typically the ground is not a significant source of moisture, but it is enough to help fuel clouds. And so with wet ground, you tend to have moisture evaporating that cools off the surface below and provide a source of latent heat to bring you those clouds which temporarily block out the sun, or even possibly give you rain clouds. But then not only that, while the ground is drying out, the skies tend to clear out as well under these systems. And with clear skies, you tend to get easier warming. And so if you notice something between a cloudy day and a sunny day, on a cloudy day it doesn't warm up that much. That because frankly the clouds are blocking the sun and not allowing the radiation to come through and heat on the ground. But with clear skies, there's nothing to block the sun, so the air just warms up easily. And then finally, warm air advection. So this is simply just warm air coming in. And so if you take a gas, remember that if you heat up a gas, it expands. And so when you bring in warm air, you expand that air. And then what happens is that this makes the ridge stronger because it's an area of warmer air. And so that with that one, it gives more reason for it to strengthen and stay around long. And then what happens is when all these feedbacks work together, they feed off one another, and this actually makes the environment a self-reinforcing process. And so it makes it harder for those drought conditions to stop. And so typically you kind of need something out of the ordinary to just break that cycle of just continue just miserable hot dry conditions that you see over in an area. So now we look at how this heat impacts humans. And so our body heat is actually determined by several factors, not just by the heat and humidity, but also how much heat is our bodies emitting, how much our body is sweating, or even how much exercise have you done. Once heat starts to get serious, for example, with heat exhaustion, we start to see minor effects take shape where you may start to experience nausea or becoming dizzy or even fatigue when your body temperature is at around 102 to 104 degrees. But then with heat stroke, at the body temperature at or above 104, you get more serious conditions affecting your basic functions and even your mental abilities. And so when it comes to looking out for heat, all the alerts come from the National Weather Service. So where you get your heat advisories, your excessive heat watches, or your excessive heat warnings. But whether one gets issued out depends on the region and the climate and the criteria for each. So, for example, for a heat advisory over Phoenix, you need the feels-like temperature or the heat index to be at above 95 degrees for at least 2 days. But for Miami, you need the heat index to be at least 105 for 2 hours. That just being that Phoenix is typically dry, but Miami is typically warm and humid, and so factor into the humidity, and you get, of course, a higher heat index. And so between a dry heat and a humid heat, which do you prefer? Well, allow me to share you the difference. And so with a drier heat, you tend to get warmer days than a humid heat. However, on the flip side, you get cooler nights. And of course, in a dry heat, the humidity is lower, and so you get those lower feels like or heat indexes. Think of a brick. It takes less energy to warm up a brick that's dry than a brick that is warm, and so on dry days there's a higher range for that temperatures can go up or down, but what's nice is that our bodies are able to cool off more efficiently, because typically in dry air, the sweat evaporates easier. On the other hand, with a humid heat, you tend to get slightly cooler days and warmer nights because of that lower range of temperature control. However, of course, the humidity is higher, and and therefore with higher humidity, you tend to get higher feels-like temperatures or the on those higher heat indexes. But now then ironically this is supposed to bring down temperatures a bit. It actually makes it feel more oppressive to be in a humid heat than in a dry heat because it's harder for sweat to evaporate, and therefore our bodies don't cool off as efficient than in the first condition. So now we want to look at what in a drought or in a heat wave, what kinds of environmental effects does this have? So one thing is blocking patterns, which I'll go over in the next few slides. But this has mostly to do with jet stream patterns. But one effect is the urban heat island effect. So you may have heard this one before, but it simply refers to the higher concentration of heat in densely populated areas like urban cities. And so when you in areas where you have more road surfaces where concrete or asphalt is more common, they're better able to hold in that heat and keep it trapped in than natural soil. And so because of this, you tend to see higher temperatures in urban cities than in more rural or less densely populated areas where there's more vegetation to absorb and release that heat. And heat can also have an impact on air quality. So one example of this is a subsidence inversion. So let's bring back the high pressure system and remember that it's bringing sinking air, and that sinking air creates a stable layer. And so in a stable layer, air cannot rise up. And so if you have, for example, a wildfire in this picture here where smoke is coming out, it just flows up but then gets trapped at a certain level. And so this may be a case where in a city you or on the countryside you'll see a haze, a brownish or yellow haze appear in the sky. But this is likely because there's a stable layer that's blocking that kind of smoke from leaving the area. So now turning our attention to blocking patterns. Our first example is the ring of fire. So it really refers to this very outside edge of the high pressure system located over the deep south. And so what is dynamic about the ring of fire is that it tends to have just enough lift and other atmospheric conditions to give us those thunderstorms and rain clouds. And typically what happens is as the high pressure system circulates clockwise, you tend to get those rain clouds that follow the edge, and we call those ridge riders. And so if you're lucky to be on the outside of the ridge, you can get possibly a rainstorm to pass over you and bring you that much needed relief. And typically this is more the most common out of all the other blocking patterns, but this one typically is common in the summer. Another pattern is the omega block, and so it typically refers to having an elongated high pressure system in the north to south direction that's wedged deep into the jet stream you see right here. But on the side you have some cut off low pressure systems and disturbances. And so, this is typically a little less common than the ring of fire situation, but typically once this happens, the system gets in a way stuck, and so what happens is the systems aloft tend to slow down or eventually stall out. But then this can be sort of a problem because if there's a high pressure just over an area, and it's just there for a long time, you tend to get drought. But under the low pressure systems, it's just constantly cloudy or rainy for while it's there, and so under those systems you get flooding situations. So this is sort of an example where you get sort of a dynamic rise in precipitation over an area, but having an abnormally low precipitation rate over the area in between, just because of a situation like this. And the last one is the Rex block, and so we call it that because it sort of resembles that T-Rex shape of those dinosaurs, but sort of similar to the Omega block. The high pressure system this time wedges itself eastward into the jet stream, and so what happens is this creates a low pressure system directly south of it. Now, just like the last one, this one takes a little bit of a while to move out because of how slow the systems move, and so this one also can bring about a dynamic drought or flooding situation. So when it comes to forecasting a heat wave or a drought, typically you want to look at the 500 millibar chart. And you want to look for an area of elevated height readings where this is usually indicated by a blue H on the map. And so typically any pressure surface will work, like the 700 millibar chart or even the 850 millibar chart. But we use the 500 millibar chart because it typically gives you a more defined accurate representation of where a trough is or where a ridge is. So you also want to look for a raised bump in the contour waves. So going back to the jet stream, a high pressure system creates sort of a heel in the jet, but a low pressure system creates a dip. And as far as temperatures go, you tend to get the most warming under the center of the ridge because that's where the pressure is the highest, and so therefore you get the higher temperatures there. And typically on the west side, if you're looking for moisture, you get moisture that's circulated in from the Gulf on the western side, and so if you're lucky enough to be on the left side of the ridge, you can get a better possibility of the atmosphere moistening up to give you a chance of precipitation. While it is quite more rare, but it can still happen. So here's an example of that 500 millibar chart, and so what plotted here are the heights in meters, and so notice the troughs right on the left and the right are co-located with this dip in the jet stream right there, and so you get lower heights right there. But then as you move towards the center, you get sort of a heel right here, and then if you go south, the heights go higher, and so right here, the center of the ridge is right over the western coast of Mexico, and of course you follow another dip in the jet, and then it curves out. So typically the jet follows this dynamic dip and heel situation all across the whole latitude of the Earth. And so now we've gotten the elements out of the way, and now we want to look at some record events. So one I wanted to show you was the July 1995 Chicago heat wave. And so I picked this one because what while this was a short time, it was also an example of how hot it could really get in a city. And what was phenomenal about this event was not really the heat, but also the humidity. And so before the ridge came in, on July 11th you had a high temperature of 89, where the heat index was only 93. So it was pretty close. So probably the air was dry. But then once you get to the 12th day, the temperatures start picking up, and notice so does the heat indexes right here, and this was a problem for the city because the city was not used to heat of this sort, and so you tended to get heat indexes that often exceeded the 110s. And then if you take a look at the lows, you during this time you just did not get much relief, as the lows climbed their way into the 80s, especially in the middle part of this event. And then and right on the side, what you see right here with where the boys are playing the war was quite a common pastime during this time. So probably it was uncomfortable, but it was kind of, but getting splashed must have been fun. So another event was the 1988 summer drought. And so, for this one, while the heat was not really really the biggest problem here, what really was a problem was the lack of rainfall that the area got. And so near across the whole summer, you just had a long period of just warm, dry conditions where you just did not get rainfall all across the area. And looking across the map, you see a whole broad section of the United States that was just caught in a severe rainfall deficit. And so without rainfall to help supplement the vegetation and crops for farmers, this resulted in a large number of losses due because of those rainfall shortages, totaling close to $42 billion. So next one is the 2011 summer heat wave. And so this one was notable for being one of the hottest summers for the United States. But one big thing about this heat wave was that there were a lot of cities in the United States that ended up breaking a lot of records, and temperatures end up staying in the triple digits for weeks or even months straight. And so so far to 2011 was the hottest summer for Texas. And as you can see across the map for the highs on August 9th, pretty much the southern plains and the west are just baking under the sun. And then one event that was more recent is the 2023 summer heat wave. So far this year is considered the warmest recorded year in history. And whether this summer will keep that record depends on the records for 2024. But we should have those out pretty soon. And so now I just wanted to show you that vehicles like our trucks and cars, they get hot in the summer. And so sometimes you leave your car to go do a 30-minute shopping spree in the summer, and then you come back and your car feels like an oven. Well, that's because our vehicles act like hot boxes. And so, for example, on a 90-degree day, if you leave your car for 10 minutes, your car can heat up to about 109 degrees. but then leave it there for 30 minutes, and it can get to 124 degrees. Now, leave your car there for a whole hour, and your car can be up to about 133 degrees. And because the heat is so dangerous, this is the reason why you must take precaution not to leave any unattended animals or even your children in the car, and when it's especially hot like this. And then lastly, I just wanted to leave you guys with some records to for the history books. And so for the highest recorded temperatures in the United States, that was 134 degrees in Death Valley. And so the Death Valley is notorious for being the hottest place in the United States because of not only being located in the desert Southwest, but it's also located below sea level, which further amplifies the ability for just heat to exasperate and climb up really high. But worldwide, the heat record was set for 136 degrees in Libya back in 1922. Now here's an interesting one for the highest heat index. So this was taken in Bahrain, Saudi Arabia in 2003. So take an air temperature of 108 degrees, a dew point of 95 degrees, and you get a heat index of 178 degrees. Just truly staggering and probably too hot to even envision for human life, right? Well, I put a star here because this record is so far an approximation for the event, but it's still to put for reference that unlike the desert in the United States, the desert over the Middle East is known for being exceptionally humid and hot at the same time. So it's not uncommon to see heat indexes get above the 120s. And then finally, the highest body temperature recorded. So this was taken by Willie Jones in 1980. Now he did not do this one on purpose, but a long story short, Willie Jones ended up suffering from a severe heat stroke during this brutal hot summer when due to the lack of being the lack of having air conditioning, and this heat stroke placed him in a coma, but however he lived to tell the story. And so if you're considering breaking records, I would not recommend attempting this one just for the sake of health. Well, guys, that is all that I have for you all. So I hope this presentation was helpful to you. If you have any questions, please leave them in the comment section or send one to my email, which I'll leave in the description. Thank you all and have a nice day. Bye.